All right, this video is going to go over the 10.4 homework. We're going to be using special right triangles and 30, 60, 90, 45, 45, 90 triangles. So to review, if it's a 30, 60, 90, then you're going to have a short leg across from a 30-degree angle, and then a longer leg and the hypotenuse, and the ratio is 1√3 to 2. And if you have an isosceles right triangle, that's going to be a 45, 45, 90. And the ratio will be 1, 1√2. You also have some Pythagorean triples, such as 3, 4, 5. Okay, let's go ahead and keep these in mind as we do the problems. So find the area of the shaded region and assume lines that appear tangent are tangent at the labeled points. So we can see that we have a triangle. And you could do Pythagorean theorem. And to do that, you could call this x. You could say x squared plus 16 squared equals 20 squared. Or notice that it is a 12, 16, 20 right triangle. In other words, it's 3 times 4, 4 times 4, 5 times 4. Excuse me. So it's a 3, 4, 5 right triangle. And what you'll notice too is that this triangle is, make that 12. And so with that being 12, area is just going to be pi r squared divided by 2 because it's a semicircle. And that's going to be pi, so your x is 12, so that's pi 6 squared over 2, which is equal to 36 pi over 2, which is equal to 18 pi. And the units on that are centimeters squared. And if we were to write out the approximation, it would be approximately equal to 56.5 centimeters squared. And there we go. All right, now with number 2, we have a square, and this square has a side length of 4. And so that makes the area of the square equal to 4 times 4, which is 16. Now the question is, how do I find the radius? Well, if I draw this all the way across, these are the same. So I have an isosceles right triangle, which is a 45, 45, 90 right triangle. And that's going to make this whole length here 4√2, and that's your diameter. So the radius is going to be half of that, and that's going to make the area of the circle pi 2√2 squared. That's the area of the circle. And that is going to end up being 8 pi. Because when you square it, it's going to be, if I were just to do this real quick, it's going to be 2 squared times √2 squared. And 2 squared is 4, and √2 squared is 2. So you get 4 times 2, which is 8. So then your area is then just going to be the area of the circle minus the area of the square, which you end up getting about 9.1 centimeters squared. All right. Next is number 3, and we're kind of running out of room here, so I'm going to go ahead and divide this up. Probably just do that here. Okay. Number 3. With number 3, the trick is to notice that, well, the radius is given as 24, and so the area of the circle, or well, the area of the sector, is going to be the central angle divided by 360 times pi 24 squared. So how do you find that central angle? Well, this is a kite, and these are right angles. And so you can see, because quadrilateral or a kite, and that's 105, that the measure of angle BOD, that central angle, is just going to be 180 minus 105, which is 75 degrees. And so I can go ahead and replace 75 for x. Or wait, actually, hold on. I want the shaded, I don't want the white, I want the blue. And so actually what I want is 360 minus 75, which is 285. So actually I want 285 up here. And then when I calculate that, I'll get, let's see, 456 pi. So 456 pi. I could go ahead and go down here. Which is approximately equal to 1,433. Okay. Great. So the next is number 4. TA is given as 12 root 3. It's a 30, 60, 90 right triangle, making the short leg 12, so the radius is 12. So the area is pi 12 squared times, let's see, 300 over 360, right? Because this angle here is 300 degrees divided by the whole thing. And so let's see, that's going to be 144 pi times 5/6. And we'll get 120 pi, which is approximately equal to 377. There we go. Okay. Next is number 7. Okay, with number 7, I'm going to go ahead and provide a few hints here. And let's see. So if you can see that I have this triangle right here, but this angle here is 120 degrees. I know this isosceles. I know this length here is 12 root 3. Well, if it's isosceles, the base angles are congruent, and they end up both being 30. Because we go 180 minus 120 over 2, and it gives you 30. So let's see. Well, look at that. I'll bet you that if I draw in that, I'm going to have a 30, 60, 90 right triangle where this length, this green length here, that green length here is going to be 6 root 3, which makes that 60 here. So that makes this 6. And so then the area of the triangle is equal to 1/2 base times height, which is equal to 16 root 3. And then, if I look at the next thing here, when I'm trying to find the area of the circle, that is equal to the central angle divided by 360 times pi r squared. What's the radius? Oh, well, that's simple. That's 6. That's just going to be 12. That's 12 squared. And so that will end up being 64 pi over 3. And so the final area will be the area of the sector minus the area of the triangle. That's approximately 39.3 square centimeters. Okay, Well, that concludes 10.4 homework. Thank you for listening.